In this video, we're going to talk about how to interpret solubility curves. A solubility curve for a bunch of different ionic compounds is shown up here at the top left of this page. And what it shows is on the y-axis is the solubility, or the amount of salt that can dissolve in 100 grams of water as a function of temperature. So you can see that the vast majority of these ionic compounds increase in solubility as a function of temperature. And this is a result of the fact that the dissolving process is typically endothermic. So as you're adding energy to the system, it's going to drive the reaction forward. And what's shown for each compound is a line of saturation. We know a saturated solution is one that can't dissolve any more solute at a given temperature. So the maximum amount that can dissolve. So if we look at potassium nitrate here, what this tells us is at 20 degrees Celsius, we can dissolve 30 grams of potassium nitrate in water. That's the most we can dissolve. If you have less than that, then you would have an unsaturated solution. So if you only had 20 grams dissolved at 20 degrees Celsius in 100 grams of water, then that would be unsaturated and you could dissolve more of the solute. Now, there is a third type of solution that can form, and that's called a supersaturated solution. A supersaturated solution has more solute in it than it should theoretically be able to hold, and that results from cooling a saturated solution. So if we look at potassium nitrate, and we'll get to a problem involving this down here, at 50 degrees, you can dissolve 90 grams of potassium nitrate in 100 grams of water. However, if you drop the temperature down to 20 degrees, you can get only 30 grams. So that's considerably less. So as the solution cools, what can happen, and it results in an unstable situation where it's essentially going to eventually precipitate out, is that initially it'll cool and you might not yet immediately see a precipitate form, or crystals forming at the bottom of the sample. However, at that point, you have more dissolved than you theoretically should. However, it is unstable and it will eventually precipitate out. So that's what we get out of the line. And we can use that to calculate how much stuff can dissolve in a given amount of water at a given temperature. So let's attack this in 3 different ways. The first problem asks how many grams of potassium nitrate can dissolve in 200 grams of water at 50 degrees Celsius. So we know that we have 200 grams of water, and the solubility is essentially a conversion factor relating the amount of solute that can dissolve relative to the amount of solvent. So given that we had the amount of solvent, we would place the solvent on the bottom in the conversion factor, and so we would be able to say that we have 200 grams of water, 90 grams of potassium nitrate can dissolve in 100 grams of water. That means if you have 200 grams of water, 180 grams will dissolve. A second problem would be if we need to know how much water we'd need to dissolve a certain amount of solute. So in this case, how many grams of water would be required to dissolve 120 grams of sodium nitrate at 10 degrees? Well, we look at sodium nitrate at 10 degrees and we see that we can dissolve 80 grams of it at that temperature in 100 grams of water. So this time we're going to invert that conversion factor because we were given the amount of solute and we want the solute to cancel out to give us the amount of water we would have need to have to be able to dissolve that solute. So you can see that we would need 150 grams of water. And the third problem we would ask, how many grams of potassium nitrate will precipitate when a saturated solution containing 200 grams of water at 50 degrees Celsius is cooled to 20 degrees. So we look and see how much can dissolve at each of those temperatures and essentially find the difference between that. So at 50 degrees of 200 grams of water, we can dissolve 180 grams of potassium nitrate. However, at 20 degrees, you can only dissolve 30 grams in 100 grams of water. Thus, you would only be able to have 60 grams of potassium nitrate dissolved in the solution. So we can tell that when we subtract the lower temperature value from that at the higher temperature, that you can see that we would have 120 grams of potassium nitrate precipitate.